working at all is not able to classify that one instance. And so if you went off of accuracy alone, you wouldn't kind of incorporate that sensitivity. Mean harmonic precision and recall, essentially what that does, that's the F1, where you're going to kind of take that sensitivity and that precision and kind of balance them together on how well you're able to capture that small minority class, but also how precise your algorithm is. So it balances that both. And so that's why it's really critical if you have class imbalance that you use additional metrics besides accuracy to really understand how your model is working. But yeah, so that's all the questions that at least I got. I'm more than happy to answer more.
Yeah.
Any other questions?
Great. I have two questions, if I may. So one is pretty straightforward. I wonder whether on the latent space or in any part of your model, you did inspection to see whether the model could tell a difference between the hospital data and the ambulatory data. So we know that the model worked for both types of data, right? Which is what you wanted.
Yeah.
But did it work because the model is just like so robust at the denoising that this latent space looks exactly the same statistically between these two data sets? Or is the model aware that these are different demographics? However, it knows how to focus on what matters. Like, I don't know if you looked into this because it's very interesting that the model did so well. I wonder if the model is just clueless that these are different things. Do you know what I mean?
Yeah, so that's actually a great question that I didn't do those experiments. But it would be a wonderful experiment to try. The data is out there, guys, but essentially my best hypothesis would be that it maybe has an idea, but it may be not as important whether or not AF is there or not. Just because, we did include the hospital data, but within the training set, we also included one publicly available data set, and that was not in a hospital setting. It was kind of a controlled setting. So both of them were essentially controlled. But in that external validation set, we were able to incorporate an additional public data set, and that was also controlled. So it's hard to say. I'm always like, I try and be positive. I want to say, it can tell the difference, but only a real experiment would be able to tell. And I haven't done that, but it's an excellent point and a really interesting research point to say, like, can we differentiate sources? And how important is that into ultimately the final classification decision made?
Yeah, all right. And my other question is, so we know that the model is great at denoising hard rhythms that are gonna fall between what, 50 beats per minute and 110 beats per minute in a healthy person, right? Um, did you do an analysis of seeing this denoising algorithm you created, this denoising network? Maybe it can also denoise speech, or maybe it can also denoise brain frequency bands. Like these other. You said in your talk, this network is kind of like a smoothing filter. Well, can it smooth other frequencies than the ones that are most prevalent in your data? And I know that would be another example. I wonder if you did any inspection of that.
That was actually a question that I talked a lot with my advisor, because it started having, once I started these initial experiments and this idea, we really kind of started talking extensively about that specific subject. We ended up not doing any experiments, but I have a whole kind of, as a graduate student, I'm sure you guys know, you guys have like your focused experiments and then like your playground of where if you had a limited time, you would go run with it. And that was one area that I really wanted to, but I just never got the time for. But we were looking at, just kind of to go a little bit further, we were thinking about testing this on hearing, specifically hearing aids that we had a contact with to see how helpful this would be. But we didn't get to explore it as much as I wanted.
And a follow-up that is along those lines would be, well, this model was trained on these light signals, right? Did you look at whether it could work with still heartbeat information, but caught with other sensors. So for example, actual ECG. I know that you mentioned you had like an actual one electrode quality control in your ambulatory experiment, in your ambulatory data collection. But I don't know. Yeah, I don't know if there's other modalities like sometimes. Yeah, I don't know. I don't know if my question makes sense, but it's related to how does it work with other sensors?
So I didn't explicitly test it on the ECG, but I have a strong intuition that it would work equally as well, just because of other publications that were published after kind of showing the benefits of using this type of method in comparable areas.
Yeah, and I'll shut up. I'll see if there's other questions. And by the way, these questions, the reason they may not have questions is because these questions are sent from like
Exactly.
students right here. But yeah. Well, Jessica, first of all, it was great seeing you, and thank you
Likewise.
so much for your time. We know you're in the middle of your day, and you took a full hour to spend with us. And that means a lot to me, to all of the students, and I mean, I'm also sure that people are gonna find this recording later on YouTube, and they're gonna be very excited about learning about your research. So, if there's nothing else, I just want to thank you. We will let you go. You know, we will stay here because this is a class that is 3 hour long. But thank you so much. Let's give Jessica another round of applause.
Thank you. If you guys have any questions, like I said, the paper is there. It says all of where the data is located, the models, and also check out my other work. It's still in revision, but it is on archive. It's related. It focuses on ECG, but I also incorporate video data. And so how can we incorporate time series and video data to kind of get more powerful estimations of different type of cardiac abnormalities. So check that out too if you're interested. But thank you so much for listening to me talk for a whole hour.
It was amazing.